Hungry? Just add water to this powder, stick it in the fridge, and after a bit, you've got some Jell-O. You're happy. But what if you thought like an engineer? What if you were thinking about taking that Jell-O and making it tough enough to where it stretches to 5 times its size and make it really strong? Well, these scientists discovered how to do that by accident.
We weren't trying to necessarily solve a problem.
Researchers at NC State are creating a material that's soft a bit like Jell-O, but virtually as strong as the hard plastic in the water bottle you use every day. It's called a glassy gel. It's a discovery that could transform industries like 3D printing and soft robotics.
So most common plastics that you encounter in your day-to-day life, like a water bottle or these glasses that I'm wearing, tend to be hard, and we call those glassy because the polymers that are in those materials are sort of stuck in a particular shape.
A glassy polymer like that water bottle is hard and solid because its tiny pieces can't move. A glassy gel is like firm Jell-O, mostly liquid but stuck in place by a solid sponge. That's where liquid and solid work together. At first, Dickey's team was simply looking at materials that go into a wearable technology and could sense body movement and heat. But they started to see some strange stuff going on.
Normally when you add liquids to plastics, they become very soft. And so that's when we had our eureka moment.
They discovered a special ingredient that made these hard materials soft but kept them strong. Ionic liquid.
Gels are all around us also. So there's things like Jell-O, for example, or tofu, or even our bodies. And these are, again, polymers, but they're surrounded by liquid, typically water. And they have very different properties, namely they're stretchy.
And they found a special sauce that changed the equation.
We think of it as a recipe where we have these ingredients like this ionic liquid here.
The materials are filled up with 60% of this ionic liquid, which is a salt solution that stays liquid from room temperature up to 200 degrees, and that gives it the advantage. The ionic liquid interacts with the polymer and spreads the polymer chains apart, making the material flexible. But that ionic attraction holds those chains in place, giving the material that harder feel.
It's very much like a towel where we have water kind of soaked up into this material. So this one has a lot more water than this, so it's much more stretchy. So they were originally the same size, but since they have water inside it, more water inside it, it's become swollen.
The best part, Dickey says, is that the material is easy to make, maybe not like Jell-O, but simple in a lab. Once those ingredients are put together, the material is placed between glass like you see here. Last step in the recipe is to put it in the oven and bake it all together.
It's UV, and the UV causes the liquid to polymerize and form the glassy gel. So it goes from being a liquid into being a solid. This process depends on how bright the light is, but it typically just takes a few minutes.
These glassy gels are sticky, and Dickey says they could have applications in adhesives, window insulation, because they don't dry out, overheat, and are simple to make. One of the things they're looking at is making what he calls biocompatible.
Contact lens, if you leave it out, it will shrivel up and become very hard and dry because the water evaporates. This doesn't do that.
There are even applications in the power industry, like batteries. Since salt is a conductor, these materials can conduct electricity, and since they're hard to break, they can reduce fire risk.
Plastics are sort of all around us, but they tend to be made in factories. We wouldn't be able to make a lot of the plastics that you find in this lab. We wouldn't be able to make them here very easily. But this material we can. We literally just mix them together and shine light, and that's it.
Thanks for watching. If you enjoy science stories like this, like and subscribe for more.